now that we have looked at the properties of the trig functions, we can start to graph them. So we're going to graph in this video sine and cosine, and then later on do the other 4 trig functions. So let's begin with just some of the properties that we discussed. We're going to start with sine and then we'll do cosine. So we have domain, range, period, and symmetry. So the domain is what you input. So in this case, it's going to be the angles. And for sine, you never have an angle that gives you that sine is undefined. So your domain is all real numbers. You can plug in any angle. Your range, your output are ratios. And because sine is opposite over hypotenuse, which we described in another video, we get that the range is -1 to 1. And the period is 2 pi. We haven't really seen yet how this is going to help us. We're going to see in this video. And the symmetry is odd, which means it has origin symmetry. This means that the points in quadrant 1 will mirror to quadrant 3, vice versa, and 2 and 4 will mirror. So anytime you don't know what a graph looks like, the best way to go is to plot some points. Do a table and just start to plot points. So I have a few angles here, and I have the axis angles. So let's just remember to help us. The point here is 1, 0. Then here's 0, 1. This is -1, 0. And this is 0, -1. And sine is the y of the unit circle. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. The other angles I have as pi over 6 and 5 pi over 6. So let's look at pi over 6. So pi over 6 is 30 degrees. So just in case, right, we can always draw a little triangle. This is 60. This is 30. This was 1, 2. And then square root of 3. So sine of 30 degrees is going to be opposite over hypotenuse, which is going to give us a positive 1/2 because it's in quadrant 1. Now 5 pi over 6 is 5 times 30 degrees, which is 150. So it is in quadrant 2, which means that sine is positive, and because it has a reference angle of 30 degrees, it's still 1/2, and because it's in quadrant 2, it's a positive 1/2. So we can plot these. So I'm going to start with the axis angles. So I have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Next, I'm going to graph the pi over 6 and 5 pi over 6. So pi over 6 is going to be 1/3 of the way in here, and that's going to be 1/2. And 5 pi over 6, which is 150 degrees, will be 2/3 of the way here, in between pi over 2 and pi. So this is going to be a positive 1/2. Now, of course, if you really didn't know what it looked like, if I didn't know, I would do more and more points. But I just kind of wanted to show you where the picture comes from. And so what you're going to have here is a nice curve where you're going to go up to 1, down to -1, and then back to 0. So here is our sine curve. And what we call this is we call this one cycle of the sine curve. But of course, remember that the domain is actually all real numbers. So it's going to go all the way to the right and all the way to the left. And this is where the period comes in. So because I have one cycle, which is the period of 2 pi, the graph literally repeats itself. Because what are you doing when you're going around the circle? You're hitting the exact same y's over and over. So once you do one revolution of the circle, the same values are going to show up again. So what you look at is you look at the y, the output patterns of the axis angles. So for sine, you are at 0, then you go up to 1, then you go back up to 0, then you go to -1, and then you go to 0. So what I'm looking at is I'm looking at these points right here. So 0, 1, 0, -1, 0. So then we're going to repeat the pattern. So I'm going to go to the right, so I'm at 0. I'm going to go up to 1, then to 0, then to -1, and then to 0. And I would keep doing this forever, but I'm out of space on my graph. Now, if you want to go to the left, you have to do the pattern backwards. So you have to read the pattern right to left, 0, -1, 0, 1, 0. So I'm at 0, I go down to -1, then 0, then back up to 1, then 0, then -1, then 0, then 1, then 0. Like you're just doing like a little bit of a roller coaster. And then, of course, we connect this in a nice continuous, that one Went a little too far, of course. And here we are. And of course, on the left, you would continue, but I ran out of space. So here is our sine graph. The domain is all real. You can see the range is only -1 to 1. Its period is 2 pi, and it's odd. So all the points in quadrant 1 are mirroring to quadrant 2, and so on. So what we're doing here is we're unraveling the unit circle. So instead of going around the unit circle, we're just kind of taking it like a string and laying it out. So how you want to think about this, right, is that from 0 to pi over 2, those are your quadrant 1 angles. From pi over 2 to pi, those are your quadrant 2 angles. From pi over 2 to pi over 3, those are your quadrant 3 angles. And from 3 pi over 2 to 2 pi, those are your quadrant 4. So that's why in quadrants 1 and 2, sine is positive, so it's above the x-axis. And in 2 and 3, sine is negative, so it's below the x-axis. Let's do the same for cosine. So the domain is all real numbers. The range is -1 to 1. The period is 2 pi. The main difference here is that cosine has a symmetry that's even, y-axis symmetry. So again, we're going to do the axis angles. So I can go up here to my little diagram that I already drew, and cosine is going to be the x. So 1, 0, -1, 0. So the cosine of 0 is 1. The cosine of pi over 2 is 0. Cosine of pi is -1. The cosine of 3 pi over 2 is 0. And 2 pi is the same thing as 0 degrees. And then we're going to do pi over 3 and 2 pi over 3. So if we draw a little triangle, we have 60. We have 2. Then we cut it in half. So this is square root of 3. And pi over 3 is 60 degrees. So cosine is adjacent over hypotenuse, which will give us 1/2. Now 2 pi over 3 is 2 times 60 degrees, which is 120. 120 is in quadrant 2, and cosine is negative in quadrant 2. So because it has a reference angle of 60 degrees, it's 1/2, but because it's in quadrant 2, it's -1/2. And then we plot. So again, let's plot our axis angles. So 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. And then pi over 3, which is 60 degrees, would be about 2/3 of the way in here. Not about, it would be. And 120 would be about right here. And that would be a -1/2. And again, if you really didn't know, of course, you would maybe have to do more points. But I will connect it for you. So here it is. And there is our cosine graph, our one cycle. So 0 to 2 pi is one cycle. And the graph is going to repeat forever, all the way to the right and all the way to the left, because you can keep going around the unit circle forever. So the pattern for cosine is first it's at 1, and then it's at 0, and then it's at -1, and then it's at 0, and then it's at 1. So again, what I'm doing is I'm looking at these axis points here. So if we want to repeat the pattern to the right, I'm up above at 1, I go down to 0, then I go to -1, then I go to 0, and then I go to 1. And again, I would connect this, right? This is not lines. You should be graphing it like a curve. Think of like a roller coaster. And then if I go to the left, I'm going to do the pattern right to left. So I go to 0, and then I go to -1, and then I go to 0, and then I go to 1, and I go to 0, and then -1, and then 0, and then 1, and then I'm out of space. So again, you connect this in a nice continuous curve. So they're like little mini parabolas that go up and then they go down and so on. And this would continue on forever. So here's my graph for cosine and here's my graph for sine. They do look similar, but keep in mind that they start off differently, right? Because sine starts off at 0, 0 and cosine starts off at 0, 1. So yes, they have the similar shape, but they are a bit different. And so in the next videos, what we're going to do is we're going to use these basic graphs and we're going to perform transformations on sine and cosine.